Hello students, today we will be knowing how to find the inverse of a square matrix, a 2 by 2 square matrix. So let us start with our answer. First of all, let us name this matrix. Let the name be A. Let this matrix A be equal to 3, -2, 7 and 14. These are the 4 members of this 2 by 2 matrix A. Now we have to find the inverse of this matrix A. So what is the inverse? The inverse of this matrix A is given by, inverse is written as A to the power of -1. So it is equal to 1 by det A into adjoint A. So A inverse or inverse of this matrix A is equal to 1 by det A into adjoint A. Now we see that this det A means the determinant of this particular matrix A. So this is in the denominator. So the value of this det A cannot be equal to 0 because it is in the denominator. If the value of the determinant of any matrix be equal to 0, that matrix is termed as a singular matrix. So we cannot find the inverse of any singular matrix. We can find the inverse of only non-singular square matrices. So first of all, let us find the value of this determinant of matrix A. So we write det A equal to 3, 7, -2 and -4. First of all, let us write the elements of this matrix A in general form. Since the matrix is named as A, we are writing the elements as A small a. The matrix has been termed as capital A, named as capital A. We are naming the elements of this matrix A by small letter, small a, and A11, these two subscripts represent the row and the column. This first one is for the row and the second one is for the column. That is, A11 is the element in the first row and first column, that is this one. Next is A12, that is first row and second column. A21, second row and first column, and A22 is second row and second column. So these are the general members. So det A will be equal to A11 into A22, that is A11 into A22 minus A21 into A12. Now let us put the values, the numbers. So A11 is 3. So we are having 3 into A22, second row, second column, that is this one, 14. So it is 3 into 14 minus A21, second row, first column, that is 7 into first row, second column, that is -2. So 3 times 14 is 42 and -7 times -2, which is equal to a +14. So 42 plus 14 gives us a 56, which is not equal to 0. Therefore, matrix A is a non-singular matrix. That is, the determinant of this particular matrix A is not equal to 0. So we can find the inverse of this matrix A. We have found the value of det A. That is this part. We have to find the inverse of matrix A. So we have found the value of det A. Now we have to find the value of adjoint A. Now what is adjoint A? Adjoint. Let me write the full word. This is the rough work. This is rough. It is adjoint. ADJOINT. Okay. So I know that you all know, but still, just for a revision, it is adjoint A. Adjoint A is equal to the transpose of this particular matrix. C11, C12, C21 and C22. Transpose of this particular matrix. Now what are these things? C11, C12, C21 and C22. These are the cofactors. Again, let me write the term. It is cofactors. Okay. Now let us first find the values of these 4 cofactors. How do we find them? C11. The name implies C stands for cofactor and 1, 1 means the first row and the first column, that is this element or this element. So C11 is equal to minus 1 to the power of, we'll be adding these two. Okay. So it is 1 plus 1 into, next what we do is, since it is the first row and the first column, we will be excluding the first row and the first column. We will be excluding the first row and the first column from the matrix A, and we will be getting the remaining number as 14. So we will be multiplying this with 14. So minus 1 to the power of 1 plus 1. 1 plus 1 is 2. That is simply minus 1 whole squared, which is equal to a plus 1, which when multiplied with a plus 14 will be giving us a 14. Now coming to C12. C12 is equal to minus 1 into, to the power of 1 plus 2, because 1 plus 2 into, now it is the first row and the second column. That is the first row and the second column. We will be excluding these two, the first row and the second column. And we have this number 7 left with us. So we will be writing this into 7. And minus 1 whole to the power of 1 plus 2. 1 plus 2 is 3. So it is minus 1 whole cubed. And minus 1 whole cubed is equal to minus 1. So minus 1 into 7 gives us a minus 7. Next is C21 equal to minus, let me write this. It is C21 minus 1 to the power of 2 plus 1 into, now it is the second row and the first column. Second row and the first column. So second row and the first column. First column, second row. Left number is remaining number is minus 2. So we have minus 2. Minus 1 to the power of 2 plus 1, that is 3. So it is minus 1 whole cubed, which gives us a minus 1 into minus 2, that is plus 2. Minus 1 times minus 2 gives us a plus 2. And finally we have C22. It is minus 1 to the power of 2 plus 2 times, it is the second row and the second column. 2, 2 is second row and the second column. That is second row and second column. We will be eliminating these two. Second row and second column, we are having this number 3. So it is 3. So minus 1 whole to the power of 4 into 3. Minus 1 whole to the power of 4 is a plus 1 into 3 is again a plus 3. So we have got the 4 cofactors. Next we will be substituting these values in this adjoint A. Adjoint A equal to, in place of C11 we will be writing 14. In place of C12 we will be writing minus 7. C21 is 2 and C22 is 3. And we will be taking the transpose of this. That means the row will become column and column will become row. So we take the first row and make it as the, we write it as the first column. That is 14 and minus 7. Next we take the second row and we make the second column. It is 2 and 3. Now what is A inverse? A inverse is equal to 1 by det A times adjoint A. And what was the value of det A? Det A is equal to 56. So we will be putting the value of det A. It is 1 by 56 into this matrix, adjoint A. Adjoint A is not a number, it is a matrix. So we write this as 40 minus 7, 2 and 3. We can keep it as it is, or we can multiply every member, every element of this inverse A matrix by 56, 1 by 56. So we can write this as 14 by 56, 2 by 56, minus 7 by 56 and 3 by 56. And we can just cancel these two. It becomes now 40 into 4 is 56. 14 into 4 is 56, right? 14 times 4 is 56. So we get the first member if we just simplify these. So we get the first element as 1 by 4. And second element is 1 by, how much will this be equal to? it is 28. And minus 7 by 56, that is minus 1 by 8 and 3 by 56 will be kept as it is because we cannot simplify it anymore. So this is our answer. Therefore, A inverse is equal to 1 by 4, 1 by 28, minus 1 by 8 and 3 by 56. Okay, so this is the answer. Or we can write this as what was our original number or original matrix. Do you remember that? See, this is 3 minus 2, or this is 3 minus 2, 7 and 14. We can write it this as well. 3 minus 2, 7 and 14. Inverse of this implies inverse of this is equal to, because in place of A we are writing the matrix, is equal to 1 by 4, 1 by 28, minus 1 by 8 and 3 by 56. So this is our answer. Let us just highlight this part as well, since we have highlighted the first part, the previous one. So let us highlight this as well. We have found the inverse of our given matrix, that is this one, 3 minus 2, 3 minus 2, 7 and 14. So the inverse of 3 minus 2, 7 and 14 is 1 by 4, 1 by 28, minus 1 by 8 and 3 by 56. Thank you for hearing.